Welcome to the third video in this series on completing the square. In this video we're going to be looking at how you use the completed square formula to find the vertex of a graph. So this here is a quadratic graph, so it will look something like this, a nice U shape, and the point right at the bottom here we call the vertex. So our goal is to find the coordinates of that point. Now the first thing we do is complete the square on the graph, but we're going to need to write y equals at the front because it's a graph this time. So if you remember, half the coefficient of x, so half of 8 is 4, so x plus 4 all squared. We square 4, which gives you 16, then take that away, and then subtract the 3, which is already there, and then simplify that, we get x plus 4 all squared, and then negative 19 when we simplify negative 16 and negative 3. So we've written this quadratic graph now in the completed square form. So how do we find the vertex? Well, the vertex is achieved in this case by finding the lowest y value. So all of these points on this graph have a y coordinate, and at the vertex the y coordinate is as small as possible. So to make the y coordinate as small as possible, we need to make sure that this function here, which is equal to y equals x plus 4 all squared minus 19, is as small as possible. And the way we do that is we look at this bracket here. So this bracket here is going to be some number, and we do some number squared. Now when you square any number, it will always come out positive. So if you do negative 5 times negative 5, positive 25. If you did 4 times 4, positive 16. So the lowest we can possibly make this bracket here is 0, 0 squared, which is 0. We can't make it negative. So if I were to make this bracket 0, then I would need to have x equal to negative 4. Since negative 4, add 4 gives you 0, and then I have 0 squared. So when x equals negative 4, y equals 0 squared, subtract 19, which is negative 19. So now I've made y as small as possible, which must mean that these two here represent that coordinate. Now I can't write my answer like this, I have to write it in a coordinate form, negative 4 for the x coordinate, negative 19 for the y coordinate. So simply all you do is write it in the completed square form. To get your x coordinate, you look at the opposite sign of the number that's in the bracket. So if it's plus 4, negative 4, plus 7, negative 7. If it's negative 2, positive 2, negative 8, positive 8. And the last term simply comes from this bit here, whatever this is. If it's negative 19, negative 19. If it's a plus 2, plus 2. Okay, so here are some practice questions for you on this. Press pause, write down your answers to these, find the vertices of the following graphs, and then press play when you want the answers and I'll tell you what they were. Okay, here are the answers then. So for this first one, we need to complete the square. We get x plus 5 all squared, subtract 25 plus 20, which is y equals x plus 5 all squared, and then subtract 5, which gives you a vertex of negative 5, so I'm on the opposite sign of this, but then the same sign as this, which is also negative 5. This next one, I get y equals x subtract 2 all squared, subtract 4, subtract 13, y equals x subtract 2 all squared, negative 4 subtract 13, negative 17, so I get a vertex of positive 2, that's the opposite sign of negative 2 here, and then negative 17. And for this final one here, y equals x subtract 3 all squared, subtract 9 plus 21, y equals x subtract 3 all squared, and then plus 12, and then a vertex of 3, 12. Okay, let's look at one slightly harder example. So if you've watched Completing the Square Part 2, you'll know how to complete the square on something more complicated like this. In terms of finding the vertex, the same logic still applies. So we're going to factorize the 2 out of every term first, like so, and then complete the square on the bit in the bracket, which is x plus 2 all squared minus 4 minus 3, and then y equals 2 lots of x plus 2 all squared, take away 7, and then multiply back through by the 2 lots of x plus 2 all squared, subtract 7. So this is in a slightly different form, but the vertex is still easy to find because I still want negative 2 because of this bracket, and then I still want negative 7 here from the end term. So the only difference is you're going to have a number out here. It needs to be in this exact form, but that number won't affect your decision when finding the vertex. Here are some practice questions for you to have a go at them. Press pause, write down your answers to these, and then press play when you want the answers. Okay, so for this first one we're going to factorize a 3 out, so y equals 3 lots of x squared plus 6x plus 1, and then y equals 3 lots of, now inside the brackets we complete the square, so we have x plus 3 all squared, we're going to take 9 then plus 1, y equals 3 lots of x plus 3 all squared, negative 9 plus 1 is negative 8, and then y equals 3 lots of x plus 3 all squared, subtract 24. So the vertex here is at negative 3, negative 24. This next question will factorize 4 out, so 4 lots of x squared minus 2x minus 6, y equals 4 lots of, now I complete the square, x subtract 1 all squared, 1 squared is 1, so take away 1, take away 6, y equals 4 lots of x subtract 1 all squared, subtract 7, multiply back through, 4 lots of x minus 1 all squared, 4 sevens are 28, so negative 28, which gives you a vertex of 1 and then negative 28. And for this final question, factorize 2 out, so 2x squared minus 8x plus 7, so y equals 2 lots of x subtract 4 all squared, subtract 16 plus 7, y equals 2 lots of x subtract 4 all squared, negative 16 plus 7 will give you negative 9, and then multiply back through, 2 lots of x minus 4 all squared, subtract 18, and then the vertex here would be 4 and negative 18. That completes the third video in this series on completing the square.